Sunil Dutt, welcome to the
Hey,
podcast.
Robby. Thank you. Great to be here.
Nice and jet lagged, huh?
Yeah, indeed. Actually, I landed yesterday morning at 6 o'clock in the morning from the US. Tried to
Mm,
stick it all out until the evening. Unfortunately, that was not a big success.
yeah,
So I'm going to try again tonight.
yeah. And you're in the Netherlands, correct?
Based in the Netherlands, in a lovely city called Rotterdam.
Mm.
So it's the harbor city of the Netherlands.
And 28 degrees.
Yeah. 28, well, actually 32 already. So
Okay. Oh,
it is quite hot.
jet lagged and sweaty. Perfect. Perfect for a podcast.
Perfect combination,
Yeah.
indeed.
I was at a conference last week in Norway with 1,100 people, and having this episode in mind, I attended a session about what was it called? The OWASP top 10 for APIs. I'm sure that everybody listening. I'm hoping everybody listening to this has like a light understanding of what APIs are, but we might as well just take that. What is an API and how is it used these days?
Everybody is digitalizing, meaning that they're utilizing a lot of cloud technology, adopting a lot of microservices. Obviously, they had a ton of software running around already, but the true magic really happens once customers start integrating all those components together, making
Mm,
sure that the software, cloud, microservices can actually exchange information. And that's exactly what the API does, right? If you really break it down, the whole purpose of an API is to expose information, it is to expose data. I think the best example is the whole open banking principle that we're now seeing across the financial institutions. But we all know that everywhere where data and information is being exposed, obviously you'll have some bad actors that are trying to get their hands on that information for their personal gain. So APIs have been responsible for a lot of digital transformation and innovation, but it unfortunately comes with a downside that we need to be mindful of.
mm. And I mean, it's kind of hard to ask this question without having a concrete example, but okay, fine, like a bank. How many
Yeah.
APIs do you think they have running?
Well, that is the magic question, right? There's this phenomena called API sprawl, which basically means that the amount of APIs that are being put into production is growing so extremely fast by all the innovation that's being taken place at our customers that it's simply, customers don't have the resources, time, or any, documented methodology to actually register all the APIs. So that is one of the first things that you need to take care of. And obviously, in a lot of the security controls, like NIST, CIS, obviously you need to have visibility of your estate, and that is one of the first things that we do at Salt is provide full visibility in a discovery phase of all the APIs that the customer has running.
Interesting. Can you give
Yeah.
us just an example? And I haven't asked you to prepare this example, but like one application, right? That does a. Can you provide an example of like one simple application that actually has like hundreds of APIs running to make that application work?
Absolutely.
Yeah.
Well, maybe we should just stick with the example of banks,
Mm,
right? If I just, flip out my mobile phone and I look at all the banking applications that I have, all the transactions that I'm doing, probably those applications are connecting with one, the bank itself, two, the provider of the credit card, maybe American Express, Visa, MasterCard, whomever is providing the service, but then also connecting with the third party service that's connecting your bank with maybe a web shop.
mm,
And that can be tons of connections because obviously we're shopping at maybe 100 plus web shops, right? So all those connections have to be written. The developers actually need to determine what type of information will be flowing over the API. And yeah, I can tell you there's a lot of what we call PII data, the personal identifiable information that's flowing over those APIs to facilitate the ease of use and, helping me to do online shopping and making sure that my bank can connect with all those third parties. So there are a ton of connections. There is a ton of APIs being put into production, and there's a lot of sensitive information flowing over those APIs. And, to kind of expand a little bit on that question, this also kind of paints the picture of why all of a sudden these APIs are very attractive to the hackers, right? Because if you look at the world previously, before all this digitalization, you would have few APIs, and the APIs didn't even have access to sensitive information. But if you look at the world today, with the example that I just gave you, these APIs are growing exponentially. It's a huge attack surface and access to sensitive data. And there you have it, the perfect equation for the hacker to all of a sudden shift their attention to the
mm,
APIs.
mm. You
Yeah.
say it's a huge attack surface. Is that because there's so many? But they're all
Yes.
configured differently and.
Exactly, exactly. And yeah, that's an interesting point that you're raising. They're configured differently. They're actually super unique because most of these APIs are being developed in-house at the customer, meaning that these APIs only exist at that one particular customer, and they're super, super unique. So can you imagine that if you are a hacker, you basically cannot use any breach that happened across the world on an API level as a blueprint or as a reference for you to understand how to penetrate the defenses of another API, because these APIs are so super unique.
It's at least good.
So what the hacker, which is absolutely good. Well, what the hacker then needs to do, they need to spend a lot of time in what they call the reconnaissance phase, right? They spend days, weeks, months, we've seen examples of more than a year, to fully try to understand the business logic of that unique API before they launch an attack. So, this already tells you how super complex this world is becoming, and why hackers really love to now shift their attention a little bit more towards the APIs versus traditionally the endpoint.
Interesting. Can you expand a little bit on how the attackers are actually doing that reconnaissance and actually, doing the recon, the kill chain? What's the kill chain of an attacker for an API?
The kill chain and the evolution of the APIs is very similar to endpoints, because we started off with endpoints on simple antivirus, and look at all the complex technologies that we have today with EDRs and XDRs and what have you. So we see the same evolution on APIs for the simple reason that if you look at the kill chain before all the digital transformation, the attacks on API levels were very simple. It's what we call the one and done attacks. A hacker would try to get maybe a piece of malware hidden in a piece of traffic across to the other side, towards the customer. Customers would typically have traditional technologies like a web application firewall, or maybe even an API gateway that could do deep packet inspection, detect the malware, block the traffic, right? And the customer would be safe. It's fairly simple. But if you look at the world today with all that digitalization and all those APIs flying around, what the hacker nowadays does, they actually get in reconnaissance mode for a very long time, and they stay below the radar. And once they have figured out the business logic of that specific API, the hacker would then launch an attack that is not one single attack, but it's taking place over a very long period of time. And customers that don't have technologies in place that can interpret context over a longer period of time simply cannot detect or block those types of attacks, because they see the traffic as legitimate traffic and just let it pass through. And what also customers often think is that authentication layers will help them. Well, I can tell you that nowadays hackers also bypass those authentication layers very easily. I'll give you an example. This is a live example that we had with one of our customers last quarter. This was a bank in Spain that was under attack for 8 months. So the hacker, basically what they did, they paid somebody a sum of money. That person opened an account with the bank. That person requested internet banking login credentials, got the credentials sent at home, shared everything with the hacker. The hacker logged in with legitimate credentials that were just acquired legitimately, and was able to invest 8 months of time to fully understand the business logic of the API, launch what we call a low and slow attack, which is taking place over a longer period of time and is not detectable by, for instance, a WAF or an API gateway, and was able to exfiltrate customer information, customer banking data, et cetera, right? So these are the things that are happening nowadays, and it's a completely new problem that is arising, and obviously that requires a new approach as well.
So, not a pen tester or whatever, but like say you get into my bank, right? Does he just like inspect the traffic, just inspect the codes that inside the bank and just put it all together? That's how you understood the logic. And then when you say low and slow attack, did he try certain things and that didn't work and say, okay, so go back to drawing board, and that's low and slow, that he keeps trying certain whatever attacks and then finally gets in? Like, can you explain that a little more in detail?
Exactly. So it has multiple aspects, because once they're in, they can try multiple things. They'll try to figure out the way that the API is configured, right? So maybe it's an API that has access to a database, and reference number 1 gives access to a certain record. But what if we change reference 1 to reference 2? Will they give me access to a different record? Hey, it actually did. You know what? I'm going to write a script that's going to automatically work the reference from number 1 to number 100,000. And within a couple of minutes, the hacker has access to 100,000 databases, records in the database. What they also do is they try to mimic authentic traffic. So once the hacker truly understands what an authentic API call looks like, and particularly a sequence of API calls over a longer period of time, they will mimic exactly that sequence, and they will get traffic across to the other side completely undetectedly. What can be hidden in the traffic? Maybe it can contain malware, maybe it can contain ransomware. But the big danger is that once they have access to one API, it is very easy for them to jump to another API and another API because they're in. Right? And these are attacks that are happening under the radar. And that's where this is becoming a true challenge because existing technologies cannot detect them, cannot block them. And it's not only us that are saying this, because we're seeing this at our customers. You just mentioned OWASP, and also Gartner and many other analysts are now very vocal about the fact that you really need to redesign your security strategy around APIs. You need to add additional layers, and particularly discovery and the API protection part that is going to give you more advanced protection against those threats that are documented in the OWASP API top 10. And particularly the first one, the first attack in the API top 10, it's what we call the broken level object authorization, otherwise known as the BOLA attack. It's responsible for more than 40% of all the attacks that are happening on an API level. And simply because it's for the hacker, it's a very easy attack to launch, but from a detection and response perspective, it's a very, very hard attack to detect and to block because it's happening over a very long period of time. We can go on this topic really for hours because there's so much to tell about how, all the different techniques that hackers are using per API attack. But it's super interesting, and it's something that we need to take into account nowadays.
When you say that they're using so much time, right? Like an attacker using 8 months. What did he get out of that? Like, what can you actually access? Is it just everything the API is connecting to? Is it what's the
exactly.
Why would they invest so much time in it?
Exactly. Well, maybe I can give you another example. I think this is the most famous example that we have in the world of API security. Is actually the example of Facebook. Facebook was subjected to an API-based breach for over a year. It took them more than a year to find out that they were actually subjected to an API-based hack, but already millions of customer records and data were already leaked through that leaky API. And can you imagine that a company as Facebook is probably spending more money, time, and resources on security than the average enterprise that you and I are talking to on a daily basis? But even if a company of that magnitude can be breached and be breached undetected for over a year, that really tells you how super complex API-based breaches are that are taking place over a longer period of time. Let me kind of give you an example through an analogy. So, for instance, if we travel a lot, we use hotels. So I check into a hotel and I get a room key. That is authentication, right? I'm officially authenticated. So then I go to my room. That key allows me to open the room, which is completely normal behavior. So nothing strange is going on. But what if I try to all of a sudden open one more room? What will happen then? Obviously the room will not open, but there's nobody from the reception that is coming up and checking, hey, mister, you're trying to enter a different room, because they obviously assume that it's maybe a mistake. But what if the next day I try a couple of more rooms and a couple of more rooms and a couple of more rooms? There's nobody going to come up to double check if I'm doing anything that is maybe malicious, because I am already checked in as an authenticated user of the hotel room, but nobody actually knows that I'm trying to get into other rooms as well. And that is what is happening with these API-based breaches as well. They come in authenticated. They are mimicking behavior, which is perfectly normal, right? No alarm bells go off. But under the radar, they are actually doing a lot of stuff that they shouldn't be doing, but the existing technologies simply don't recognize it because they're either not looking for it proactively, or secondly, they cannot put together the context of things that are happening over a longer period of time. And that is exactly what you need to have from a technology perspective to be able to detect these super complex attacks.
So if you talk about the market for a little bit, and I want to make this a commercial podcast, but I mean, it is interesting to see what are customers doing, which are what are, you mentioned, what did you mention? You mentioned a web application firewall, an API gateway. What are they trying to do with those products that isn't working?
Well, a couple of things. So typically what a web application firewall or a gateway would do, they would actually inspect the traffic if anything malicious is going on. So that is like comparable to looking at individual pictures and trying to identify from each and every picture if you see anything in the picture that is maybe off sync or not or wrong. What they're not capable of doing is putting all those pictures together and turning it into a movie, because an individual picture can look perfectly fine. But if you look at the sequence of multiple pictures put together, you can actually see that the sequence of multiple actions is something truly malicious. And that's why a technology that is aware of context, that can analyze a ton of information spread across weeks, months, maybe even more than a year, and can derive from the context that we're seeing that actually something malicious is going on, that is what these technologies are missing today. And don't get me wrong, right? So Salt Security, we're not here to replace the WAF or the API gateway, because API security is actually not a product. It is a technology stack. Gartner actually in August 2021 actually published their new reference architecture for API security. And they added one more layer, which is API detection and protection. And that is the layer that Salt takes into place. And well, it tells you two things. Well, first of all, API security, it's not a product. It's really a strategy that you need to implement, which has a technology stack attached to it. But the second part it tells you is that we are not replacing any existing technologies. We are integrating with the existing technologies to offer protection against the most advanced threats that are documented in the OWASP API top 10 that you spoke about earlier.
So it's you're not those other products, the web application firewall, this is not meant to do that.
Exactly. Yeah. It's not designed for that purpose, which is perfectly fine. But you need to start adding technologies that can help you get protected against those very advanced threats.
So if you look at Salt, I'm assuming you have competitors that are doing non-web application firewall stuff. You have like some competitors that are doing similar things to you, right? What is the difference between if you just look at the market as if you put your Gartner hat on instead of your Salt hat on, like what is the difference between the vendors that are working with this, since it's relatively new, right?
I'm going to give you two separate answers to that question, because if I have to give you the most honest answer in terms of what is the competitor is the old way of thinking. It is the belief system that existing technologies are offering sufficient protection against these advanced threats, which causes, it puts us in a situation that we are evangelizing and educating the market a lot. And Gartner is extremely vocal about API security and why you need to rethink the methodology around that. So I think most of our time is being spent on educating the market, educating the customer on this new phenomena together with the analysts. Obviously, API security, it's super hot at the moment. You see a lot of stuff coming by around API security because there are also a lot of breaches attached to it nowadays. And in any market that's heating up and is getting towards the top of the hype cycle, you will see new players enter the market as well, which is only a good thing, because if you are the only one in the market talking about a topic, then you're probably not that relevant. And it's actually a good thing that we see multiple players that are now talking about the same topic, educating the customer as well. If I have to say what's the true difference, a couple of things. Salt Security actually pioneered API security in this way. Before Salt, there was no API security in this way, in this shape or form. We've been around now for 5 years. We have a ton of customers that we're already servicing. And which gives us gives us insight to a lot of breaches that already happened, a ton of information that we've already analyzed. We already know exactly what we need to look at to be able to provide that protection to our customers, because the solution is based on AI and ML. The downside of AI and ML, which is, by the way, absolutely needed to be able to analyze a ton of information that is required to detect these anomalies. But the downside is that AI and ML-based engines have runway, right? They need to learn, which means that in the first year and a half, you'll have a ton of false positives because probably you're detecting stuff that's not even there. And that is what new players that are coming into the market only now, what they're dealing with. They're struggling with making sure that the AI and ML engine actually reach a level of maturity that they can actually detect anomalies that are actually there.
Yeah. Interesting. It's a blessing and a curse to be the first. You have to educate the market, but yeah.
Exactly.
When you somebody listening to this, right? Could be a bank, could be an energy company, could be anybody, right? How do they go about finding out how many APIs they have?
Any type of cybersecurity strategy always starts with visibility. You cannot protect what you cannot see. And once we get to a point that the customer admits that probably they don't have visibility of their full API estate, that's exactly what we will help them with. So what we will do is we will make a mirror of all the API traffic. And from that traffic, we can determine what types of applications, APIs, endpoints, maybe even the end users are generating that API traffic. We are just capturing the traffic natively from an option that already exists in the technology that they already have.
So you just point the traffic somewhere and it goes to your engine, then you put it back to where it's supposed to go, basically?
Exactly. Yeah. So we make a mirror of the traffic, we fully analyze it, and we can extract the APIs from that moment.
And then, so then once you have like visibility, and so then you have the visibility, and then you can detect things, right? How do you, does your product also, I didn't want to make this a product discussion, but if you're the only one, I have to ask you, like, is your product also helping you to like put an API safely in production then, basically, like helping you build it properly?
Absolutely. So if you look at the market, you have two common themes that you see passing by. You have shift left and you have the shift right. We're very passionate about the fact that you need to protect everything that you already have in production first. Because if you're a hacker and you're going to scan the network of a customer, you are going to find the APIs that are in production first, right? So you need to make sure that you have runtime protection applied to everything that you have in production. Secondly, you get to the point of shift left. Shift left meaning you take all the APIs that are still pre-production that you still need to launch, and you will thoroughly test those APIs and analyze if you need to make any adjustments in the code or the API itself before you put it into production. And the way that we do it is we expose the API to all the anomalies that we've already seen in the wild, including the OWASP API top 10. We also apply our best practices to it and provide our findings to the DevOps or the DevSecOps teams on where they need to harden the API before putting it into production, so you're actually safe from day one.
So you're basically scanning the code, just like any other scanner, but just the API as code then, not any other code that would be produced.
Correct. So I'll give you an example. Some of the things that we sometimes find in APIs is overexposing sensitive information in the response code, right? So, we're sticking within the financial segment of examples. So one of the things that we sometimes see is that if the banking application gets a request from a web store, that they actually feed back too much information, which might include an IBAN number or a full credit card number, right? That's probably not required in the response, and we can detect that and then give an advice to the customer that, hey, it's probably a good idea if you just remove that information because it's not required. And by the way, it's PII data, so not compliant from that sense either.
Yeah, and they do it's set up like that because they expect the people on their side to just use what they want and not use anything else, I guess.
Exactly. And the complexity, to that point, I still remember, when I started at Salt and I was talking to the first CISOs and security architects, they had the assumption that the developers were actually putting all the APIs into production in a safe way. And when you were talking to the developers, they assumed that the security teams were adding a security layer to the API.
Yeah.
So
like they do with everything else.
There you have it. Yeah. So you have this massive blind spot.
So where's the future of this area? I'm assuming you're not going to be alone there forever. So but what are you expecting to come? Like, what are some of the what's on the roadmap?
Yeah, so a lot of things obviously are developing in the worlds of APIs because the whole purpose of an API is also developing. We are now seeing that many customers are now also applying what they call event streaming, which is a different way of applying these APIs. So that's definitely something that we're homing in on as well. But it's also making sure that you can support all the API development platforms, right? You have the GraphQL, you have REST APIs, you have so many forms of APIs that are hitting the market for very specific purposes So you really need to make sure that you're able to capture all those APIs and interpret all the traffic to be able to, well, one, detect them and also offer sufficient protection to those customers as well. And you'll see that we are very, very passionate about offering protection in runtime, right? Because everything that you have in production, you do not want to take it offline because that's going to be unplanned downtime and it's going to cost customers a lot of money. And we're also very passionate about the fact that you need to have a cloud-based big data backend that does all the number crunching and analytics for the customers without them having to install 20, 30 servers of, with a lot of compute power to be able to analyze all the traffic. Obviously, that's not scalable. It's not good for TCO either.
So where does Gartner put you in the hype cycle?
Well, that's an interesting one. Gartner actually just released the new hype cycle report for application security. I think they released it now 3-4 weeks ago. You'll see that API security has a very, very prime position in there. And we're also seeing that the market is responding to that as well, right? You can immediately see that API security by itself as a domain is being budgeted. We're receiving multiple RFPs in that area as well. So things are moving extremely fast at the moment.
Cool. Last question. Why salt? Like not the technology, but why the name salt?
It actually has to do with the fact that salt is an essential mineral for any living organism to survive on this planet. And in the same way, salt from a security perspective is also essential to your security strategy. So everything around salt has to do with the essential part of making this, part of your core strategy. But if I can still a little bit expand on my personal response on why salt, it really has to do with the company culture. It is, we call it the salt family, and it's called like that for a reason.
Cool. Well, thank you very much for your time. I'm sure I'll be talking to you again after this podcast.
Absolutely, Robby.
Cool.
Thanks a lot. Thanks for having me. And have a good one. I'll talk to you soon.
Thanks. Ciao.